So this is the interface of the site emission tool. It's an Excel with two tabs, input and output. So in the input tab, you fill in some information about your site and also the rewetting activities you are planning for. And the output tab will show you the emissions for the two scenarios. So I will go through it a bit quickly right now, and I will only talk about the highlighted areas. So first, you fill in some general site data. It's important here to fill in your total area, so in hectares, as well as peat type and peat thickness. So here we determine the peat thickness to be 30 centimeters. Then we go to the baseline scenario, and here it's important to fill in your median groundwater level in summer and the vegetation class. So if we would imagine here our baseline would be a dairy farm in a peat meadow area. For example, the groundwater level could be minus 60 centimeters below surface, and the vegetation class would be dry to moderately moist grassland. By filling in your groundwater level in summer, the tool would limit the choices you have in vegetation class. So if you would open this drop-down menu, you would see different types of vegetation classes, and it would be your choice to choose the most appropriate one. It might be a bit difficult to choose the vegetation class, so I advise you to play around with it a little bit, choose different types and see what the different scenarios would amount to. As well, so we would do the same for the rewetted scenario. Here, our median groundwater level in summer would be 15 centimeters above surface, because in this scenario, we want to rewet, but we also want to harvest, grow and harvest taifa for building material. So the vegetation class that would be most appropriate would be very wet tall sedges and taifa. But of course, if you want to have a different vegetation class, you can choose the ones that are available at this water level. Additionally, you can fill in some other options about fertilizer use, as well as land management. You can see here. So important here is that we only fill in the rewetted scenario that we expect a crop yield because we grow taifa, and the yield would probably be around 5 tons of dry matter per hectare. There will be some crop residue left, and the crop we want is taifa. But in a drop-down menu, you can also choose, for example, reed or sphagnum. Additionally, the crop use in the rewetted scenario would be to use it as building material for insulation, but there are also other applications you can choose from in this menu here. So going to the output tab, the tool gives you a short overview of the site, and then an overview of the baseline scenario. So the guessed is actually the amount of methane and CO2 based on your vegetation class and the groundwater level. So GWP is the global warming potential in CO2 equivalents per year. So we expect here 31.4 CO2 equivalents per year emissions based on your vegetation class and groundwater level. The tool also takes into account other factors, but I won't go much further in detail here about these. In total, your global warming potential would be 33.6 for your baseline scenario, and that's also shown here in the graph. So the tool does the same thing for your rewetted scenario, and here your global warming potential would be around 6 tons of CO2 equivalents per year for the taifa at the water level we filled in. And also important to note is that we have another value for product use, and that's a negative value because here we assume we use the taifa as building material. So the carbon that's stored in a taifa and that will be used as building material is actually emission reduction, because it replaces fossil fuel products in this case. So here it's a negative value, of almost 9 tons of CO2 equivalents per hectare, per year. And again, the total amount of global warming potential for your rewetted scenario would be minus 0.8, and that's shown here as well in the graph. Lastly, the tool shows you the estimation of your carbon credits you can validate for, and that's basically the difference between your baseline scenario and your rewetted scenario. And you can see it here in the graph. So the green line is the baseline scenario and the blue line is the rewetted scenario. The difference between these two is the yellow line, so that's about 35 carbon credits you can validate for until 2035, because that's the point where in the baseline scenario your peat would have been lost, so you can no longer apply for carbon credits that are based on emissions avoided, but only the emission that are reduced, so the emission reduction based on your product or land management, or if you would actually have a carbon sink, so carbon sequestration at this point. So that's why the line drops here. The tool was developed during an Interact project, CConnects. It's still available on the website, so you can download it there. And it also has a user manual which explains a bit more of the parameters that you can fill in the input tab, and also explains a bit more the values in the output tab.